In this video, we're going to go through a job. It's been a customer project on some fan blades. And what I'm going to go through is I'm going to show you the job, and then I'm going to walk you through. The job just finished early this morning. We ran it later yesterday morning. It was about a 15-hour job. And so it's ready to eject. So I'm going to show that. I've got the Easy Post Process system from SLS4ALL, and I'm going to show you. We got that set up yesterday. Kind of had some issues regulating the air, so we're going to go through that process so you can kind of see some of the challenges you may have with it, and then we'll go through the cleaning process, obviously. So let's first then go over to the computer and look at the job. All right, so here's the print job that was printed. So you can see these fan blades, they're nested in here, and also I've got some tensile bars. So for every print job I do tensile bars, and that way I can basically, for this particular job, I can kind of make sure everything is properties are, where they're at, not only the density of the parts but also the tensile strength. So you'll see that in here. Now, unfortunately, because I don't have any other parts to run today, the nesting density is only 9.5%. This is horrible. You want to get closer to 30%. You can see this is uses up quite a bit of the chamber, and so this is the job that's run. So we're going to go ahead now, go over to the printer and eject the cake, and then we'll go ahead and start cleaning at the Easy process. All right, so we'll come over here to the job. All right. It's still not a complete seal, so I don't like that, because I got powder sifting out of here like crazy. So I'll lift it over. So still not 100% of dust free. Now I will tell you, so I do a couple things. Here I run a filter over here to help keep the any dust away from the machine. So here we have our cake. So we're going to go ahead and get the vacuum on, and then we're going to go ahead and turn this sieve on, and we're going to keep an eye. One thing that we need to keep an eye on is over here in this. You'll see this is a two-stage. So this is the primary, and what happens is we'll see some, obviously if this is too strong, we'll see a lot of the powder start to collect in there, which means if it's collecting in there, it means a lot of it's probably getting to the vacuum filter as well, which we don't want. So we use this restrictor plate that came with it. Now I've had it all the way open, and but I don't think that's enough suction, so we're going to play with this as we do this, and maybe we can observe together. So let's go ahead and turn on the vacuum and turn on the sieve. Okay, so I just thought it'd be better to talk over the vacuum, and you can see here, first of all, I need to adjust the restrictor here to control the vacuum pull. So I want to make sure it's a kind of a balance. You want a balance between the vacuum pulling and also limit the amount of powder that collects in that secondary collector there. So you'll see me checking here, paring down to look at it periodically, and I'll may need to open up the restrictor a little bit more to kind of limit the overflow into that secondary. So that's kind of the key right now is what you're going to see me doing here, and kind of looking down at that. You can't really see in this picture, but you can see there's some collection in there, not too much. But I open up the restrictor here to kind of limit the amount of powder that's flowing into that second. Now, so I start breaking down the cake here. Obviously I should have protective gloves on at this point. The kit does, actually the EPP kit does come with several brushes and several sets of gloves. But anyway, you can see I removed the first part. You know, the cake is pretty hard, and I take my time brushing and chipping powder away from the parts until they break free. And then I'll clean each part individually as I remove it from the cake. So as I kind of get that bulk material chipped off, I'll rub it down and break it down as it goes down through the sieve. So the good news is I'm not noticing any powder dust in the air. I think even though the vacuum's open all the way, so that's always a good thing. So it seems like I'm getting good flow of powder through the sieve and limiting the amount that's in that overflow. Although I'm still getting some collection in that overflow, it's not excessive at this point. All right, so for this part, I basically use a pick to remove the bulk powder between the blades. And even though these are really strong and tough parts, I still want to be careful around the blades. But once I get the bulk material off, then I'll use the brushes to remove the remainder of the powder. Now, these blades individually, they take about 15 minutes to clean up the majority of the powder. So an interesting note on these parts, the customer was having these fan blades 3D printed in aluminum for about $300 a piece. Now, when we talked to them about SLS technology using PA12 powder, they went ahead and had us print a couple of samples, and then they cycle tested these at the 18,000 RPMs for over a week, and there was no failures. They were impressed, and so they went ahead and buying functional production parts from us now, and it's about a third of the cost to them to have made as SLS. So actually a pretty good deal for them, pretty good deal for us. So this is a good use case for customers who have low production volumes for a part that would not make sense to tool up. So after cleaning, we'll weigh each one of these parts and we'll calculate a density. We'll measure some critical dimensions as well as run the tensile bars to get an average tensile strength of these parts. Now, we target a 0.98 to 1.02 gram per cubic centimeter density, and tensile strength we're looking for somewhere between 41 and 45 megapascals. Now, any lower than these would indicate there was an issue with the laser quality or potentially the powder. So that's why we measure these, just to make sure that the quality and consistency of these parts are the same before they go out to the customer. All right, so we've got our parts all cleaned up here now. So like I said, we have the 4 fan blades, and then a little, and then I did 4 tensile bars, and we'll test those here in a little bit. So 4 gives a good representation. So we'll have to get those, the blaster. So a couple things on this processing station. So overall, pretty good. Now I'll use the secondary hose to clean up. The only main problem I'm seeing is I've got some sort of issue going on. It seeps around that screen, so it piles up right there. So I don't like that. The other thing too, and I forgot to put the static charge on this when I removed it the first time. This is about half full. I dumped it once, and even at the restrictor full open, it still collects more in there than I would like. Now that's already filtered and everything else, sieve, so I should be able to dump it directly into the bucket. So a couple things I thought about doing is to keep it more contained in the box is I do know how much powder I have in there that needs to be refreshed based on this one cake. So I can add fresh powder. I can add it through the sieve, and then it goes into the system, or I can just open up the box, but if I do it through here, it'll stay contained. So that was something I thought it would be a good way to mix it. Now I would just have to mechanically mix it, but at least the powder would already be in there, and it would limit how much fresh powder is out in the open being in the dust. So with that said, we've got to clean up our printer now. get the residual. We've got the over powder bin that will dump, since that hasn't been exposed really to the heat or anything. That can go directly into the refresh powder. Back in the refresh powder, we'll definitely sieve that though as well. So that's kind of the process. And like I said, we just put this lab together a couple weeks ago. We're still kind of getting it set up with our different 3D printing technologies. And we've just like a box. That's still too low, so definitely that's going to have to go higher, at least for me. My back was starting to get sore leaning over that. Same thing with the printer. I plan to put a platform under it and raise it up a little. So I still don't like the cake transfer. It still allows for some sort of dust. It's not 100% contained. You can see the mess there. So we may have to relook and see how we can modify that. One of the other things we did was we plugged in a energy meter, and for this 15-hour job, it used 5.25 kilowatts. So you can see it doesn't use a lot. Our energy here is 15 cents a kilowatt hour. So you can see it's under $1 to run energy for this system. And probably by the time I don't have it hooked up to this processing station, but I can't imagine it'd take much more energy. Really, the majority of the energy is from the heating. So very low cost, frankly, to operate. So if you're concerned about the energy consumption and in your cost calculations, it's really about a buck a job is about what we put in. Okay, now as part of the processing station, it comes with this long hose. So now what you do is remove this cover, and you've probably seen Thomas in his videos. But this actually will go down in here. So this just, there's a couple notches, and then it just turns counterclockwise to fit in there. Let's see. Well, it wants to be difficult today. I got some really sharp edges on this thing, and that's another thing I don't like on the tensioning bands. I also don't like this 100%. I wish it actually was more like a brushes, so we can reprint something maybe in TPU that helps us do that better. I'm going to put this electric static in there. So, okay, now once you have it in there, you basically just do everything as well. You turn on the vacuum and sieve, and we can do this area first. See, I just don't think it's, I'd rather see a smaller nozzle on this, so which is probably what I'll do, so I can get in the crevices a little bit better, because I don't like the nozzle that they provided. It's just kind of awkward, to be honest with you. This works really good on the flat surfaces, but we need to make an adapter to a quick adapter so you can remove these without having to undo the clamp. But it definitely works on the flat surface, but like where it's spilled out of this sieve, I can't get down under here as well as I'd like to, because it just won't. So that's why I think that's not the right tool for it. But on flat surfaces and getting in the corners, it's not too bad. And then we'll just take a slightly damp cloth probably and do the surface. So that's kind of it. I'll get the printer cleaned up, but you can kind of see now that we're pretty much clean in there. So we'll go ahead and finish the printer and then we'll start assessing our parts. Okay, so we're all cleaned up here, and I did a few other stuff here. So I've got to address this sifter, and I think we have a solution. I think I'll come in here. So this fits in there pretty firmly, but what I think we need to do is we're going to add some sealant material in here and see how that does on any sort of future leakage here. So we'll keep that out because I'll need to get that. We'll have to get that mess cleaned up there. One other thing too that we're thinking, there should be no reason why. I just don't think this system is very effective. I mean, I was able to use this system on when I used to at least just vacuum, no sieve obviously, but it would capture the majority of the powder. And this, I'm still seeing overflow, even with the restrictor opened up. I'm still seeing more powder in that secondary stage, which means it's probably something's getting into my vacuum, and I particularly don't like that. So what I'm going to do is actually I am going to use this and put this in line here, and then just double into this. I'll capture the majority of my sieve powder in this bucket. I just think it's better, and then we can assess that and see how well it collects. So that's in regards to this system. So I know we got a lot in this video, but I just kind of wanted to show the improvements that we plan to do for the processing station, because as it is now, I don't like this setup, and so there's some work here. So we've got a lot of design changes that we think could really improve this. So all right, so after the print job and we went through the process, I said we noticed some leakage, and so in this part here, the screen, it fits in there tight anyway. What we ended up doing was we put a little gasket material here, a little foam, it compressed, and then when I ran some more powder through it, quite a bit of powder actually, it actually didn't leak anymore. So I think there needs to be something in the kit that provides an extra barrier there. There's just nothing there. So I think that's one. So two is this system over here. So this is what came with it, and it had this and the overflow, and no matter how much I did on the restrictor, I was still getting plenty of overflow in that secondary. So over here in this, too much powder, and if there was getting in that, then it meant it was probably getting into my vacuum. This here is I think it's called the Oneida Dust Deputy. I bought this last year when I built my system just to clean out my powder chamber before I had the whole sieve thing, and I attached this actually in there to see how well it would work. It literally captures like 99.7% in this system here. Now my vacuum cleaner, it runs at about 1,000 watts. It's an 8 amp vacuum cleaner at 120 volts, so a little under 1,000 watts. They say, you know, a 1,200 in their instructions, but bottom line is this is a lot more efficient. This is, I personally, maybe they've had better luck. I think this was a waste. I wouldn't even need this. I don't even need the secondary. I hooked it in, I kept it in line just because I wanted to see. The other thing is this is just wieldy. You take off these, you got this big old bucket. This is so much easier. I just lift it off. Just pop that little thing there and it lifts off, and I have access to my powder, and it's a lot easier to mix it as well. In fact, I can run new powder through this and then just mix it up and refresh at the rates I need to. So as far as dust collection, you know, the EPP, you know, listen, it ended up costing me $1,500 with shipping, and then it cost me another $188 in the tariffs, custom duty fees So, you know, we're talking close to $1,700 for this and that. And frankly, I think most people, I think this wasn't worth it. I think, and if you're in the U.S., just having one of these dust deputies is probably, even if you wanted, you could rig up a secondary if you wanted, but I don't think it's necessary. And then just overall, I would say in terms of, you know, I think it's a decent design, but in terms of the overall, I think they could keep this out of it and have us provide our own, or find something similar. And but overall cost, the shipping in the U.S., I personally, I don't think this system is worth that cost for what you get. I think this could be obviously redesigned. Overall, a decent design, as I said, for this with the sieve. The dust collection system needs some work. I think it's just unwieldy. It doesn't work as effectively as I think they would like it to, especially when it comes to refreshing. And having a more of a bucket that's easy to carry than a big old thing, it just makes a big difference. So that's kind of my thoughts on this overall system. Okay, one of the other things that we talked about improving on this was this hose. This is the one that was used. It connects to here, and then you could use this to clean up your station and your printer. So they provided this piece here, and it was actually connects directly to the hose. So this is flat. It's good for flat surfaces, but it's really not good for getting into tight spaces, especially like in this, underneath this container screen here. And so getting the tight spots, as well as tight spots into the printer when you're trying to get along the recoder rails and so forth to make sure there's getting dust out of it. This does not work effectively. So I printed an adapter that then sits on this, and then I can just attach that when I need to use it for the flat surfaces. But then I'm 3D printing now a longer nozzle, pointed nozzle, that can reach into the tight spots in this and in the printer as needed. So I think this is something I think they ought to rethink, just using an adapter here, and then they can provide different attachments for better vacuuming and cleanup purposes. Now this one's fine, just not great for all your needs. The other thing we did was we just printed a little tool caddy here. You know, they provide some brushes. You know, I actually prefer these type of brushes. They're like a toothbrush, so they got a really small end. Those are the most effective, I find. This tool caddy probably, I did a real quick 5-minute design and printed it. But they may want to consider providing a tool caddy along with these as well that can hang on here. So that's I think that was something that they definitely can add on for this. So that's pretty much then I see as potential improvements to this system, so that's my feedback to them.